What's happening, dogs? Mr. Allen here. We're going to graph this wonderful, beautiful exponential function, f of x equals 1/2 to the x plus 1 minus 3. Now, when dealing with exponential functions or logarithmic functions, I like to use smart points. And what I mean by that is I want to pick points that are easy to graph, right? Easy to calculate. So we got to do a little bit of thinking here. Well, when I have a number between 0 and 1 for my base, negative exponents are my friend because it's just going to do the reciprocal. So let's start with how about -3 for x. So -3 goes in. I got -2 in my exponent. 1/2 to the -2 is the same as 2 squared, which is 4. And then 4 minus 3 is +1. Next number, let's do -2. When I plug -2 in, I've got it raised to the negative first. So now 1/2 to the negative first, flip it, it becomes 2. 2 minus 3 is -1. Next up, let's do -1 here. Now I have 0 as my exponent. Anything to the 0 power is 1. 1 minus 3 is -2. And you know what? I'm going to go ahead and throw in 0 for x as well so I can see where it crosses that y-axis, right? This will give me my y-intercept. If I throw in 0, now I have 1/2 to the first power, which is just 1/2, minus 3 is going to be -2.5. Okay. So we got 4 nice points here. Usually you want 3 or 4 points. Let's see here. What about my asymptote? Because it does ask for an asymptote. What happens? How do we get that? Well, for exponentials, for my parent function, it's going to be y equals 0, that horizontal asymptote. If I think about transformations here, this thing is shifted down 3. So now my asymptote here, my horizontal asymptote is going to be y equals -3. Woo! Beautiful. Fantastic. Look at that. We knocked that question out and got a nice little bit for our graph here. So I got 0, -2.5, which is right here. I have -1, comma -2, which is right here. Then I've got -2, -1, boom. And then we got -3, +1. Ooh. And it does help to know a little bit about the shape of these bad boys, right? It's going to be getting closer and closer and closer to that asymptote, never crossing or touching it. And then it's going to go on up while still going to the left there, okay? This is a decay function, exponential decay. But now it's time to answer the questions here, domain and range. Domain and range always seem to confuse people, you know? Domain, just my x's, right? Don't overcomplicate it. Just my x's. Does it ever stop going to the left? No. Does it ever stop going to the right? No. Does it go forever? Yeah, forever, bro. So it's going to be x equals all real numbers. Or if you want interval notation, depending on what your teacher wants, it'd be from -infinity to +infinity. Beautiful. All right, next up, my range. Those are my y values, bro. Does it ever stop going up? No. Does it ever stop going down? Whoop! It's limited by that horizontal asymptote, right? At -3. Does it ever get there? No. Never touches it, so we don't want to include it. So you can either write it as y is greater than -3, or, again, interval notation would also work here. You could do, I'm going to actually write that right over here where I got a little bit of space. It's going to be from -3 to +infinity. That would be my interval notation of that range right there, okay? So if you want interval notation, we got those infinities, the parentheses, brackets if you're including the point, which we are not here. And then for our set builder notation, there's a little more fanciness to it, but that's the meat and potatoes right there. X is all real numbers, and y is greater than -3. Not equal to. You can't get to that asymptote. Just gets really, really close to it, infinitely close, as we go that way, okay? As we're going that way. I'll see you guys later.